He was right about going back to the moon not being a worthy enough goal for the National Space Agency of the United States of America. The President of the United States, however, did not replace the idea of going back to our moon with, in my opinion, a worthy enough pair of goals. Instead, his goals were for NASA to start visiting asteroids at some indefinite period of time and then sending humans to Mars in over 20 years. Many attendees of this convention feel resentful of the President's policy. Well, there's a simple and obvious answer to this problem, and that is for the planned human spaceflight missions to visit the two big asteroids which are the most interesting to humankind, and they are Phobos and Deimos. Mars, as we all know, has two small moons, Phobos and Deimos, which are thought to be captured asteroids. Satellites were discovered in 1877 by Asa Hall, are named after the characters Phobos, symbolizing panic and fear, and Deimos, symbolizing terror and dread, who accompanied their father, the god of war, into battle. The possibility of Martian moons had been speculated long before Hall's discovery. The astronomer Johannes Kepler even predicted their number, although with faulty logic. He wrote that since Jupiter had 4 known moons, and Earth had 1, it was only natural that Mars should have 2. Hall discovered Deimos on August 12, 1877, and Phobos on August 18, 1877, at the U.S. Naval Observatory in Washington, D.C. He was deliberately searching for Martian moons. If viewed from the surface of Mars near its equator, Phobos looks about 1/3 as big as its full moon from Earth. It looks smaller when the observer is further away from the Martian equator, and is completely invisible because it's always beyond the horizon, polar ice caps. Deimos looks more like a bright star or planet for an observer on Mars, only slightly bigger than Venus looks from Earth. The motions of Phobos and Deimos would appear very different from that of our own moon. Speedy Phobos actually rises in the west and sets in the east, and rises again just 11 hours later. Near the equator, partial eclipses of the sun are very common. Both moons are tightly locked, always presenting the same face towards Mars. Since Phobos orbits Mars faster than the planet itself rotates, tidal forces are slowly but steadily decreasing its orbital radius. At some point in the future, when it approaches Mars closely enough, Phobos will be broken up by these tidal forces to become an orbital ring. Deimos, on the other hand, is far enough away that its orbit is being slowly boosted instead, as is the case of the moon of planet Earth. When Barack Obama said he didn't want to go back to the moon but to visit asteroids instead, it is presumable that he was referring to near-Earth asteroids similar to, let's say, 1036 Ganymede, which is the largest Amor asteroid and about 32 kilometers in diameter, and gets at times closer than Mars to Earth. There is estimated to be around 500 to 1,000 near-Earth asteroids. Phobos has already been the object of considerable close examination since the 1970s, and is even now expecting robotic spacecraft to arrive care of the Russian Space Agency. Phobos, upon closer examination, is a very interesting place. It even has monoliths and pyramid-like rocks or geological features. Phobos also has a microscopic gravity well, so it does not need the Herculean engineering effort that Mars manned surface mission aerospace hardware needs. There is a very good reason for the Mars Society to start to lobby for the Obama administration to start a NASA program that would have Phobos and Deimos as their choice for future manned asteroid missions. The big reason is this: once humankind has put a man on Phobos, and Phobos with its incredibly close orbit to Mars will offer the astronauts, cosmonauts, and Chinese Yuangiangs, please excuse my pronunciation, and probably even Indian Voimanauts, a magnificent view of Mars. The humans who get there will be so amazed of the massive vista of the red planet before them that they will convince humankind as a whole of the benefits of a visit to the Mars surface, and the missions might happen almost a decade sooner. So there you have it. It makes perfect logical sense. Obama wants NASA to visit asteroids. Phobos and Deimos are asteroids. Phobos and Deimos are not significantly harder to reach than near-Earth asteroids. If the Mars moons were much harder than asteroids to visit, humans would not have been wanting to send missions to Phobos since the 1980s. Once humans land on Phobos, there will be no turning back for humankind. After the big step of Phobos, the dominoes will start to fall, as another big step is the Mars surface. Then main-belt asteroids, then moons of Jupiter, then moons of Saturn, and the spiral of human exploration of the solar system will be unstoppable. The Cold War space race met a major bump in the road when USA won the race to the moon. Then the USSR could not take the dishonor of second place and said that they were never trying to do a manned mission, but planned to use robots the whole time. And without the competition, the political will in USA disappeared. The space race, after all, had been a foreign policy statement. Our science is better than your science, therefore, our democratic society is better than your communist society. Making the big step beyond the orbit of the Earth to Mars asteroid moons will mean that in future the next steps will not need to be multiples of orders of magnitude harder, and there will be enough popularity to fuel the affordable political will. Politicians will want to fund the manned missions to Mars surface to help them get elected. There is a lot of scientific exploration to be done on the asteroid moons of Mars. Phobos is one of the least reflective bodies in the solar system. Spectroscopically, it appears to be similar to the D-type asteroids, and is apparently of composition similar to carbonaceous chondrite material. Phobos has been photographed up close by several spacecraft whose primary mission has been to photograph Mars. The first was Mariner 9 in 1971, followed by Viking 1 in 1977, Mars Global Surveyor in 1998 and 2003, Mars Express in 2004, 2008 and 2010, and Mars Reconnaissance Orbiter in 2007 and 2008. The only dedicated Phobos probes have been the Soviet Phobos 1 and Phobos 2. Both launched in July 1988. The first was lost en route to Mars, while the second did manage to return some unusual data and images. It failed shortly before beginning its detailed examination of the moon's surface. At present, the Russian Space Agency is planning to launch a sample return mission to Phobos in 2011 called Phobos Grunt, and way more than a make-up for the embarrassing failure of the past Soviet missions. It is a sample return mission, and the return capsule will include a life science experiment of the Planetary Society called Living Interplanetary Flight Experiment, or LIFE. A second contributor to this mission is the China National Space Administration, which is sending a surveying satellite called Yingyo-1, which will be released in the orbit of Mars, and a soil grinding and sieving system for the scientific payload of the Phobos lander. In 2007, the European aerospace subsidiary EADS Astrium was reported to have been developing a mission to Phobos as a technology demonstrator. Astrium is involved in developing a European Space Agency plan for a sample return mission to Mars as part of ESA's Aurora program. and sending a mission to the low-gravity well of Phobos is seen as a good opportunity for testing and proving the technologies required for an eventual sample return mission to the surface of Mars. The mission is envisioned to start in 2016 and last for 3 years. The company plans to use a mothership, which would be propelled by an ion engine, releasing a lander to the surface of Phobos. The lander would perform some tests and experiments, gather samples in a capsule, then return to the mothership and head back to Earth, where the samples will be jettisoned for recovery on the surface. In 2001, the Canadian Space Agency funded a study by Optic and the Mars Institute for an unmanned mission to Phobos known as Phobos Reconnaissance and International Mars Exploration, or PRIME. A proposed landing site for the PRIME spacecraft is at the Phobos monolith, a bright object near the large Stickney crater which casts a prominent shadow and is thought by some to be similar to the lunar monolith that was seen in the movie 2001: A Space Odyssey. Astronaut Buzz Aldrin referred to this monolith in a July 22, 2009 interview with C-SPAN. He said, and I quote, "We should go boldly where man has not gone before. Fly by the comets, visit asteroids, visit the moon of Mars. There is a monolith there, a very unusual structure on this potato-shaped object that goes around Mars once in 7 hours. When people find out about that, they're going to say, 'Who put that there?' Who put that there? The universe put it there. If you choose, God put it there." The PRIME mission would be composed of an orbiter and lander, and each would carry 4 instruments designed to study various aspects of Phobos geology. However, at present, PRIME does not have a projected launch date. All of these planned and in-development missions could be wrapped up into one manned Mars-Moon program in a similar fashion as to how the Mir 2 was mated with the space station Freedom after the end of the Cold War to produce the International Space Station, with additional bonus contributions such as the Canadarm, ESA's Columbus module, and the Japanese Kibo laboratory. The Mars Society could make this happen by acting as a skilled diplomat between the various space agencies once the basic blueprint for the idea has been worked out by the Mars Society itself. Once the basic plan is finalized, then the idea can be sold to the space programs of the world, and then they can be brought together in a conference similar to the one that started the International Space Station, which produced the so-called agreement between the United States of America and the Russian Federation concerning cooperation in the exploration and use of outer space for peaceful purposes. While there have been very considerable delays in the ISS program, it is generally considered to be an unqualified success and a triumphant achievement of humankind, both in terms of science and diplomacy. That is my argument for a manned mission to Phobos and possibly Deimos. I am a man with an advanced degree from the International Space University called Space and Society. This explained to me how humans go a little crazy about space exploration and development, similar to the mental condition that a healthy human would get when they fall in love with a significant other. When the economically viable mission to the Martian asteroid moon happens, then humanity would go crazy again like it did in the 1960s when they were trying to get to the surface of our own moon. This time, the manned mission will not be a bridge to nowhere because while going to the surface of Mars would be about